is for 12th class students. I was teaching you differentiation, and again I am continuing differentiation with this video. First we are finding differential coefficient of inverse trigonometric functions. Here, first we are finding differential coefficient with respect to x of sine inverse x. So, suppose y equal sine inverse x, and when x increase by x, then we may say y increase by k. So we may write y plus k is equal to sine inverse x plus h. So from here, if y equals sine inverse x, then x equal sine y, and from here x plus h is equal to sine y plus k. So we may write differential coefficient of sine inverse x by the first principle of differentiation, d dx of y is equal to d dx of sine inverse x is equal to, we may write here by the definition of differentiation, limit h tends to 0, y plus k minus y divided by h is equal to limit h tends to 0. Here y and y cancel, so k by h is equal to limit h tends to 0 k by, here put the value of h from here. Here h equal x plus h minus x. We may write here x plus h minus x is equal to limit h tends to 0 0, k divided by value of x plus h is sin y plus k, sin y plus k minus value of x is sin y is equal to limit h tends to 0, k divided by, here we use formula sin c minus sin d. You know already sin c minus sin d, we write here sin c minus sin d is equal to 2 cos c plus d by 2 into sin c minus d by 2. So we may write here value of c is y plus a and the value of d is y. So sin c minus sin d 2 cos c plus d by 2 y plus k plus y by 2 into sin c minus d by 2 y plus k minus y divided by 2 is equal to limit h tends to 0, k divided by 2 cos, here y and y is equal to 2i by 2y plus k by 2, and here y and y cancel, so we will write here sin k by 2. Next step, we may write here limit h tends to 0. Here multiply and divide by 2. 2 into k by 2 divide by 2 cos y plus k by 2 into sin k by 2. Here 2 and 2 cancel. Next, I write here is equal to limit h tends to 0, k by 2 divided by sin k by 2 into limit h tends to 0 1 by cos y plus k by 2. You know this value is equal to 1 into, apply here, when h tends to 0 then k is also tends to 0. We may write here limit k tends to 0, 1 by cos y plus k by 2 is equal to 1 into, here apply k equal 0, we get 1 by cos y is equal to, we may write cos y as 1 by under root cos square y is equal to 1 by under root 1 minus sin square y. Put the value of sin y from here, which x, so we put here place of sin y by x is equal to 1 by under root 1 minus x square. Dear students, this is the differential coefficient of sin inverse x with respect to x. So we may write ddx of sin inverse x is equal to 1 by under root 1 minus x square. You remember this formula, which is very important for finding differential coefficient of given inverse trigonometric function, and this is the first method. For finding differential coefficient with respect to x of inverse trigonometric function which is sin inverse x. Dear students, I will tell you also second method for finding differential coefficient of sin inverse x. See very carefully and understand very well. I will tell you a alternative method for finding differential coefficient with respect to x of sin inverse x. Suppose y equals sin inverse x, then we get here x equals sin y. Differentiate with respect to x on both sides. We get d dx x is equal to d dx of sin y. Here, since I had told you d dx of x is equal to 1, so here we may write 1 is equal to, here, since this y, so first differentiate sin y with respect to y. So here we may write d dy sin y into dy over dx is equal to 1 equal d dy sin y is equal to cos y into dy over dx. By transfer the side of cos y, we may write here dy over dx is equal to 1 by cos y. This we may write as under root cos square y, and this also we may write as 1 by under root 1 minus sin square y. Put the value of sin y here, you will get differential coefficient of sin inverse x ddx of y. Here y is given sin inverse x ddx of y, who is sin inverse x, is equal to 1 by under root 1 minus x square. This is second method for finding differential coefficient with respect to x of sin inverse x. Similarly, you can get other differential coefficient of other inverse trigonometric functions. I write at the board. You see this and learn them. ddx of cos inverse x is equal to minus 1 by under root 1 minus x square. ddx tan inverse x is equal to 1 by 1 plus x square. ddx sec inverse x is equal to 1 by x under root x square minus 1. ddx cosec inverse x is equal to minus 1 by x under root x square minus 1. ddx cot inverse x is equal to minus 1 by 1 plus x square. You learn all formulas. Now I take a question related inverse trigonometric functions. question. Find differential coefficient with respect to x of sine inverse x by a. Here, since finding differential coefficient of this function, so here use d dx. See the solution of this question. D dx sine inverse x by a. Here, suppose x by a is equal to t, and then first differentiate sine inverse t with respect to t, and then differentiate t, who is the function of x, with respect to x. So, since d dx sine inverse x is equal to 1 by under root 1 minus x square, so here we may write 1 by under root 1 minus x square. Here x is equal to x by a. 1 by under root 1 minus x square into d dx of t, which x by a. One by simplify this, we get under root a square minus x square divided by a square into, since 1 by a is constant, so 1 by a into d dx x. Here we may write as 1 by a into d dx of x is equal to a by under root a square minus x square into 1 by a, since d dx of x is equal to 1. Here a and a cancel, so 1 by under root a square minus x square. This is answer of this question, and this is called the differential coefficient with respect to x of sine inverse x by a. Students, you try yourself to solve question from exercise who is given in your book, and if any problem, then tell me. All the best.